Hello everyone, welcome to a video walkthrough of setting up the UAV Toolbox and its dependent software so that you can deploy custom algorithms to PX4 autopilots. If you're watching this video before January 2026, I've linked a pre-edition copy of the appendix of my thesis in the description below. Otherwise, I will link my thesis and you can go reference the appendix there. The setup documentation and UAV Toolbox description in those appendices are a collection of years of experience with the toolbox and are a very useful resource for getting set up to deploy your own algorithms. One last disclaimer before getting into the step-by-step portion of the video walkthrough. All of the software must be installed before proceeding, so make sure that you install Q ground control. I've noted the version that I used. Also ensure that MATLAB is installed along with Simulink, the UAV Toolbox, the MATLAB coder, Simulink coder, and the embedded coder. The UAV Toolbox support package for PX4 autopilots can't be installed when initially downloading MATLAB, but it's available in the add-on manager in MATLAB. I'll go through installing that support package specifically later in the video, so don't worry about installing that one right now. In this first step, we'll open the command prompt and run it as the administrator. So Windows will ask you for special permissions and then it will open up. The first command we paste in will start installing Ubuntu 22.04. It is important to use this command because this is the specific version compatible with PX4 and the UAV Toolbox toolchain. So we'll let that install. Now that everything is installed properly there, we're going to open up PowerShell as the administrator, and we're going to run some steps to enable virtualization on Windows. These steps are more than often required for different computers, so it's not going to hurt to run them anyway just to be safe. So those three commands you'll run back to back, and then we'll restart the computer. Once you have restarted your computer, open up PowerShell again as the administrator. We're going to run those three steps sequentially one more time. This time you'll notice that the last step is not going to require a restart. Now we're going to change the version of the Windows subsystem for Linux to version 2. You'll see a successful message there, and you can go ahead and close out of PowerShell. Go ahead and open the command prompt. This time, just open it normally, not as the administrator. Now we're going to run a WSL update command to make sure there aren't any pending updates. And then we'll give the command to install version 22.04 of Ubuntu. This step may take a while depending on your computer, so I'll go ahead and speed through it. Now you will configure your Unix credentials. You're going to need these again, so make sure you write them down. Finally, we need to configure Ubuntu, so we're going to run sudo apt update and apt upgrade. Sudo is a root operation, so this will require the Unix credentials that you just configured. Now WSL and Ubuntu is fully set up, so go ahead and restart your computer. Once you're back, go ahead and open up WSL again. This first command will set up the folder inside WSL that will house all of your PX4 code. I called mine example repo. You can call yours whatever you want. Then we'll command into the repository, and we're going to run some commands in here. The first command will be to clone PX4 into the PX4 autopilot folder. Feel free to paste that in from the appendix of my thesis. This process takes a while, so I'll speed it up. We still have some last configuration steps here before we open up the UAV Toolbox and do that setup. First, we're going to command into the PX4 autopilot folder. Now we'll check out the right version of PX4. Next, we'll run a configuration step. There's one last step to do to configure this repository, so we'll command into the Tools and then Setup folder, and then we'll run this command. This will require your Unix credentials, so enter those now. This step can take a while depending on your device, so I'll speed this up as well. Now that that's done, go ahead and restart your computer. Once you're back, go ahead and open up MATLAB. Now we'll go to Explore Add-ons and install the UAV Toolbox support package for PX4. Once that's done, you can either go straight into Setup. I chose to set up later just to show what you would do normally if you skipped this step. This setup screen process can be initiated through the add-on manager and then by clicking the gear icon. The following steps are necessary whether you've just cloned a new PX4 repository or if you've made some kind of modification in the source code itself. So first, we'll let MATLAB automatically download and install the required Python packages to build PX4. Once that's done, go to the next screen. Now you'll be prompted with the steps to clone and set up the PX4 repository. We've already been through those, so go to the next screen. Now we'll validate the PX4 firmware that we just cloned, but we're going to have to update the file path to match that folder that we created in the beginning. Just to show where that folder got cloned, go ahead and open up Linux and then the Ubuntu installation. Click the Home folder, open the folder with your Unix username. Then you'll be able to see the name of your repository. Again, mine was named example_repo. The PX4 Autopilot folder is inside of that, so I'm going to update this file path here to match. It's important to use the file path already provided when validating the firmware, as if you just copy the path from the folder, it's not going to work. Once the firmware is validated, go ahead to the next screen. Now you're going to get prompted to set up the PX4 repository that you cloned. We also already did this step, so go ahead and click Next. As you can see, some checks were done in the background in the command window. Now we'll choose our Autopilot board and our build target. So the default is the PX4 host target. I'm using a cube orange, so I'm going to select that. And I'm using a fixed wing configuration, so I'm going to select that build target. If you're not sure what airframe you're going to use, I'd recommend using the default build target. In the next screen, you'll be asked whether you're going to disable the default PX4 control. I personally like to uncheck this box and leave the control logic intact. That way, in Simulink, when I set up my controller, I can also read in what PX4 control wants to do and have a switch between the two control algorithms. It's usually a good idea to leave PX4 control available just in case you need it. You always have the option to use your own startup script, but I think the default startup script is just fine. Now we'll verify QGround control is installed. This next step asks you to open QGround control and select an airframe. You really don't need to configure this at this time. Now we'll actually build the PX4 firmware. I always check the box to delete the build folder just to make sure it's fresh. You can monitor all the steps of the process in the command window. It's possible for this first build to fail due to a Python package installation error. In my experience setting up a new device, it's relatively common to run into. This is the line that you're looking for with the raw_opt. That just indicates that we need to reinstall a Python package, which is relatively simple. As stated, we're going to uninstall these problematic Python packages. First, we'll try uninstalling the EM module. It might not do anything for you, and that's fine. Next, we'll try uninstalling the mpy module. This should do something. Make sure you confirm to proceed. Finally, we'll install the right version of the mpy package by setting it to 3.3.4. Now go back into MATLAB and complete the hardware setup screens the exact same way before. I'll go ahead and speed through until the point where we build the firmware. Check the box to clear out that PX4 build folder, and now I'll try again. Just like last time, you can monitor the steps throughout the process in the MATLAB command window to make sure that nothing is hung up or that nothing has failed. Now that we're done building the firmware and the hardware setup screens, go ahead and connect your Autopilot over USB to the computer. It's important to do this sometime before clicking into the next screen so that the screens pick up the COM port of the Autopilot. If you do click to the next screen before plugging in the Autopilot, it's not a big deal. You can manually enter the COM port. Go ahead into the next screen to deploy the firmware to the Autopilot. This will allow us to use the different methods offered in Simulink for bench testing and flight testing. With the COM port of the Autopilot either automatically selected or manually inputted, click Upload Firmware. This will open a dialog box that will ask you to reboot the board. Go ahead and unplug the Autopilot, click OK, and plug it back in within 5 seconds so that the computer can read the bootloader port and start the firmware upload. Once we get the status message that the firmware upload was successful, go ahead and click Next and finish the hardware setup screen process. The Autopilot is now set up and ready for the different testing modes available in Simulink.